And welcome to Chapter 7, chugging along in this book. All right, Chapter 7 is a very short chapter, and it's all about exponents, stuff you should have learned freshman year. So, the first thing we have here are our laws. Oh, my pen's not coming up. All right, our multiplication law. When you multiply, you add the exponents together. When you divide, you subtract the exponents. And now this little where x does not equal 0 and a is greater than b. Well, the reason why they say x does not equal 0, because if you had a base of 0, 0 to no matter what is going to be 0, and it has its own little set. You can't have 0 in the denominator. So there are a couple of other things that can't go on. So just pretty much ignore that where x does not equal 0. It's not going to bother you. And that only happens in division. And then the power law, when we take something that's raised to a power and then raise that to a power, the shortcut is just to multiply the a and the b together. And of course, as noted down here in bright yellow, this only happens when the bases are the same. That's when these laws apply. Notice all the base up here was always x. All right, so we're just going to run through some easy examples, and that's it, just these 5 examples. X to the 5th times x to the 6th. Well, we remember our multiplication means we really just add the exponents together, and I get x to the 11th. Now to prove this, x to the 5th would be 1, 2, 3, 4, 5, and then x to the 6th would be 1, 2, 3, 4, 5, 6. So how many x's did I have all together being multiplied? That's right, boys and girls, 11. The second example. We've got 2a to the 3rd all raised to the 5th power. Now this is really saying I have this fraction 2a to the 3rd over a squared. It's telling me that I have that 5 times. 1, 2, 3, 4. So there it is, 5 times. And notice I have both the denominator and the numerator 5 times. So my answer would be 2 times 2 times 2 times 2 times 2, which is 32. a to the 3rd times 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 a to the 3rd. Well, the shortcut is add the exponents together. So 3, 6, 9, 12, 15. And then on the bottom, I have add the exponents together because this is all being multiplied. 2, 4, 6, 8, 10. Now we're not done with that problem, but I did it out the long way to show you how easy it is to make sure we really learn these shortcuts. A power to a power told us to just multiply. So notice 3 times 5 got me the 15. And then I had to multiply also the 2 and the 5. And that got me 10. But notice also that coefficient of 2 is being raised to the 5th power also. So that is why we had to do 32. Now what we have here is a division problem. And I don't want to write out 15 a's and I don't want to write out 10 a's. So let's remember our law. When we divide, we subtract exponents. So I have the 32 still on the top. a to the 15th, a to the 10th is a to the 5th. Nothing left on the bottom, and that's my final answer. Now we have a little division problem here. Well, first things first, I'm going to rewrite this without the division sign. Awesome, that's the way we should see it. So this is asking me to square negative 5x. Well, I'm going to do that first. Negative 5 squared is 25. X squared is x squared. Now I have still a division problem to do. All right, what's 25 divided by negative 5? Negative 5. Now I have to do my variables. Well, 2 minus 2 is 0. And if I recall, anything to the 0 power is really 1. So these x squareds really just cancel out. That's another way to look at it. Oh, got myself another division problem. All right, let's take the ultimate shortcut. Let's see if we can just cancel away. Negative 3 and 15. That leaves me with a 1 and a negative up top and a 5 on the bottom. 3 goes into 3 once, 3 goes into 15 5 times. X to the 5th and x to the 3rd, I simply subtract and get x squared. And this little old y has got nobody to cancel with, so it stays on the bottom. And that's my answer. The last problem, number 5. Let's get rid of some of this stuff. Let's put number 5 up here where we can see it. Alright, this is about as hard as it's going to get. So let's see. I kind of look at it and I go one step at a time. That's 6. Nothing's happening to it, so I just write it down. This AB they want me to square. Okay. A squared, B squared. And this C to the 5th, nothing's happening. Let's see what they want me to do on the bottom. They want me to square the 3AB. Alright, so I'll square that. 9, A squared, B squared, and the C, nothing is happening to it. Now, I can divide. Well, I've got my fraction out front here, which I'm just going to reduce because they're numbers. So 3 goes in there twice, 3 goes in there 3 times. Lovely. An A squared and an A squared cancel out. Beautiful. A B squared and a B squared cancel out. Tremendous. And I'm left with C to the 5th divided by C. Well, that's really an exponent of 1. So 5 minus 1 is 4. Done.